Okay, everybody. Welcome here. Make sure you have the right microphone. Yes, I do. Okay, so we are now starting off here with Unit 2. Now, so this is going to be specifically with borrowing money. Now, this one for sure here, this is the when will I use this in real life? This is when you'll use it in real life. This is the class. This is the unit. Sorry, where like this has real practical things, and you'll find that out here in like even just a minute here. Um, Before I kind of jump into this, actually, I'll just jump straight into that. Like, why is this useful? Like, what is this for? Now, for example, if you go and do car, if you walk into a car dealership and you're like, I want a car, and usually you finance with the dealer, they're going to give you a bunch of options. Now, they're not going to give you these options with these exact amounts, but here's why it's important to know. If you were to borrow a loan, in this case, it's $200. For a car, it'd be like 20. But a bank loan, 5% compounded quarterly to be repaid in a single payment after 1 year. A bank loan at 5% compounded quarterly with payments of $51.57 every 3 months. Or a loan from a friend in one or more payments totaling $212 at any time within the year. Which one of those is better? You have to do some math to figure it out. Now, when you're in the car dealership, the smart buyer, for example, will be calculating stuff out. How much is this going to cost me in the end? Which one of these is the cheapest option? Because, for example, if you go and buy a car, you can get up to, don't write this down, you can get up to 7 year loans. Yay! This is bad. This screws you. This screws you really hard because the difference between a 5 year loan, which was the standard 10 years ago, and a 7 year loan is double the interest. So instead of paying two, three, $4,000 in interest, I'm now paying on eight, nine, $10,000 in interest just in those 2 extra years. So this is an important math to understand here. Um, so before we kind of jump into it, there's a few things we need to know. Um, make this text a little different color. Black. Here we go. So there's a few definitions we need, so make sure you guys are writing this down. But basically, a loan, oh, a loan is money that is borrowed and paid back over time, right? We know what the principle is. I'm not going to talk about that again. I'm not going to talk about But basically, right? Right, that's what it is. I'm not going to talk about principal and interest. You should know that from the previous unit at this point. Now, many real world loans use compound interest, right? Now, we've talked about this before, but basically, this means that the interest is calculated on the principal and previously earned interest, right? Again, refer back up to your notes up above, but right, month one was $50 in interest on $1,000 loan. Well, on month two, I'm calculating that on $1,050 now. Now, a couple terms here. So, come on. How often interest is added is called compounding frequency, right? And that can be stuff like every month, every quarter, so every month, every quarter, every year, so on and so forth, right? Usually tends to be like once a month, right? That tends to be how the world kind of runs here. Now, we did establish that more frequent compounding frequencies, right, means more interest, right? So if my loan, like a credit card, compounds daily, as credit cards do, they do that so that you, the customer, have to pay more money than if it were to compound every month. So more compounded frequencies means more interest. And as a reminder, guys, like I kind of just go full speed here. Pause the video if I'm getting ahead and you're still writing. Okay, that's on you as an online learner. Pause the video and come back to it. All right. So why are we talking about this? Why are we re-talking about this? Well, this entire unit is about borrowing money, and it builds on the principles that we learned in Unit 1. So when we have, generally speaking, the world works off regular payment loans, right? When I buy my car at the at the end of the day, we figure out how much that is. We break that down into a month by month payment, right? So for example, last time I bought a car, every single time my month to month payment was $350. I paid $350 in January, February, March, April, May, and so on and so forth for a couple of years. That was what that was. That's a regular payment loan, right? So many loans are repaid through regular payments, and that's usually every month. Usually. Each payment will include interest and principal. Now that sounds simple enough, right? Well, of course, I know that it's interest and principal. Here's where that matters though. So here's where this matters. Okay? So at the start of a loan, a larger portion of the payment goes towards interest instead of the principal. Over time, as the balance decreases, right? The total amount I owe decreases. More of the payment goes towards paying off the principal. Now, to give you a little visualization of this, right? Let's assume here's two car loans. So let's use my house as an example. So I own a house. So if you own a house, and let's say, for example, your monthly payment is let's pick $1,000. Keep numbers easy, nice and easy. You own a house and you have a monthly payment of $1,000. Now, on let's say year 1 January, right? Your first payment versus year 20 of January. 25-year mortgage, that's near the end, right? That $1,000 here is going to get broken up. It's going to get broken up. So on the first payment here, oh, no, I want a straight line. I don't want that. So on your very first payment, there we go, something like that. Very first payment, this here is going to be your interest. Look at how much is going to that. Maybe that's $900, right? And the rest of this here is going to the principal. Again, let's assume it's a $200,000 house. I just paid $1,000, right? Maybe my total loan at the end of it is $250,000. That's the cost of the mortgage, right? That's the interest. That's what the bank's charge is like, aha, that's our profit. So $250,000 is the total loan here. Now, in this specific example with this interest here, after your very first payment, maybe I owe $249,000 and $900. So of $1,000 payment, only $100 went to the principal, for example, right? This is just an example. Now, instead though, if you look at like much later in the loan, right? 20 years. Oh, well, now most of my money's going towards the principal. That's what this means, okay? As a concept, that's what this above paragraph here is saying, right? So in this case, maybe now I still owe, let's say $50,000 on my loan, right? But now, after this monthly payment, maybe now $800 is going towards the principal instead of the interest, for example, right? So that's where this really boils down. So really important to understand that concept because that's how the world works. That's how your car loan works. That's how your mortgage works. That's how your business loan works. That's how any loan you as an individual, as a consumer, as a customer will probably experience. Every single major loan you do is this. Okay. Is there anything else I want to talk about? Yes. Okay. There's a few more things here. Collateral. Now, what is collateral? It's an asset that is held as security against the repayment of a loan. For example, if I take out a mortgage, right, for a house, they will hold they might hold my savings account. Maybe I have $10,000 in there and my $20,000 car as collateral. AKA, if I do not pay my mortgage, the bank goes, screw this. This sucks. We're taking your crap, your car, your savings account to help cover our losses. Okay? The final term here is a red line. So the final term here is a amortization table. What is this? This lists regular payments of a loan and shows how much of each payment goes towards the interest charged and the principal borrowed as the balance of the loan is reduced to 0. Okay, so this table just shows you this like chart up here on like number form, and you can see there's an example here, right? So let's draw ourselves an actual table here. Make that black. Let's draw ourselves a nice little table. Go this, so that's month. Here's the payment. Here's the interest paid. Here's the principal paid, and here's the balance. Right, so here's the month. Here's the payment. Here's the interest paid. You can see there's a formula there, which we'll get into in a second. Here's the principal that's paid, and here is the balance remaining. Okay? So, for example here, in this specific case, this person's borrowed a $12,000 car. So let's just use a $12,000 car example is what we'll use. They're using a jet ski. We're going to say a car though. And before I go into that, your interest paid formula, your balance times, actually no, we'll get to that later. I want to focus on the concept right now, not how to solve it. Right? So, yay, I took out a loan. I don't pay anything. I don't pay anything at all. Yay. Very start, I don't take out the loan. I took out the $12,000 and that's it. So in this case, 12 grand is the balance. Now on the first month, this person did a $350 payment. The interest on that payment was 50 bucks. We'll learn how to calculate that later. And the principal was 300. And so this means his balance is $11,700, right? On month 2, remember, as the loan gets older, this shifts. So I'm still doing a $350 payment, but now my interest paid is only $48.75. So my interest has gone down a little bit. Of that $350, more of it is now going to my principal, which means more of it is going to my total balance of how much I owe for the car. So I hope that's making some sense here, and so on and so forth, right? Maybe by month 3 it'll be $47, then $46, and eventually at the very end, I'm not paying any more interest. It's all going towards the balance. Okay. So this here is an example of an amortization table. So before we jump into the rest of this unit here, so some general like rules of thumb, right? Rules of thumb with loans, because you even saw it with me. It's really easy to make mistakes with this stuff. You miss one number on your calculator. You just have a little bit of a brain fart, right? You're daydreaming a little bit. Logic is where it's like, oh, that doesn't look right. That's the part that kicks in for that. So generally speaking, if you have a higher interest rate, you pay more interest. Right? If you have a longer loan, you pay more interest. If you have larger or more frequent payments, you pay less interest. And we'll talk about that later. This is going to be one of your assignments, is going to be looking at like a common housewives tale on a mortgage, for example, where instead of, it's a month by month payment, so 12 payments a year, yay. What if you just pay an extra 13? What if you just pay a 13th payment at the end of the year? How much is that going to shorten your loan? So you'll do that later. And then as time passes, more of the payment goes towards the principal instead of interest, right? That's this above table up here. I think that's everything. Okay. So with that said, let's jump into this here. So I'm going to go to no, we don't really want to do it. We don't want to do a full table here. But we do want to take this formula here. This formula right here. So formula. Yeah. Formula for interest paid. So it's P times I, right? Principal times interest, or it's your balance times what's the way I can put it here? So it's your balance times the interest rate divided by number of payments. So for example, so first off, box this. For example, here, if I were to give you here, example one, if I were to give you a 5% interest rate and monthly payments here, for example, right? I'm going to use this loan here. The balance part I don't really care about in this case, but it'd be the balance times 0.05 divided by 12. Just as you see it on your book there to the left. Right, so that's what that would be there. So again, if you're looking at this, here's your 5% interest rate. Here's your monthly payments. If this was weekly payments, that'd be 52. If it was 10% interest, it'd be 0.1, and so on and so forth. With that said, we're going to jump straight to example 2 in the book here. So here's example 2 on page 83. Come on, computer. So this one here is solving for future value of a loan with a single loan payment. Save yourself some future reading when you come back to this stuff. So here's the question here. Pause the video, write that down. Okay, so let's look at this loan. So Trina's employer loaned her $10,000. Give me 1 second. Yellow. Loaned her $10,000 at a fixed interest rate of 6%, compounded annually, to pay for her college tuition and textbooks. The loan is to be repaid in a single payment on the maturity date, which is at the end of 5 years. Okay, so those are all important facts to understand, right? And just for the sake of this example, right? Ooh, here's her principal. Here's the interest rate. Here's like the compounded annually. It's just like that's just the thing that's not doesn't stand in for like an algebra thing. Repaid in a single payment, same thing. Maturity date, same thing. 5 years. There's our term. There's our T, for example. Actually, N would fall here as well. All right. So once you have that in, how do we solve this? So question 1 here asks, how much will Trina need to pay her employer on the maturity date? And what is the accumulated interest on the loan? So it asks you two things. So how are we going to solve that? So remember, you already have all the tools you need from the previous unit to solve this. This is a compound interest question. This is one of the things we've done. So you could just scroll up all the way to unit one, or you could look at your formula sheet. Now, this is printed off and this is given to you at this point, but it's also on the introduction page of the LMS. And hey, it's compound interest, right? So we're calculating compound interest. And what am I calculating? Am I calculating the principal or the total investment of the loan, the principal plus the interest? It's the principal and the interest, right? I don't care. I know what the principal is. So I write my blank formula, right? A is equal to P to 1 plus I to the power of N, right? When I put to the power of N, it's that little thing. In this specific case, I will draw it. But again, normally I'm going to write it. So I'm doing that just to get you guys used to that terminology. So I'm still trying to find A, but I do know that my principal is $10,000. And then it's 1 plus, remember, interest. Here's my balance, 10,000. Sorry, my interest here. Again, your interest is equal to the percentage divided by the payments per year, as we discussed up above, right? So that is plus the percentage is a 6% as a decimal. And she's paying how many times per year? Once. It's compounded once. We'll close that out. Now it's to the power of n though, right? Really easy to make mistakes. So that's to the power of 5. So this is what it should kind of look. Ooh. This is what it should kind of look like when you're writing it down. Again, I'm not always going to do that. You saw that was a lot of work compared to me just like doing it, typing it out. So just be aware of that. There. So if you do that, A is equal to $10,000 plus, this is 1.06, right? 0.6 divided by 1 is 0.6 to the power of 5. So now I should be able to take my calculator. Actually, I'll use the same one you guys are using. $10,000 bracket 1.06 bracket to the power. Where's my power button? It's where's my power button on this thing? Second function. This. Oh no. Zero six to the power of. Where's the power button? Sorry guys, it's not a calculator I generally use very much. Okay, I figured it out. It's actually done exactly how I write it out, which is weird. This is weird on a calculator, but so $10,000 times 1.06. Your power button is this little thing here. Just how I do that little arrow, that's what it is. Yeah, that's what it is in this calculator. If you're not using this calculator, it's going to be this little where is it? Y to the power of X. It'll be this button here. So just be aware. This will be that button on a normal calculator. So to the power of 5, I can see then that my loan is A is equal to $13,382.26 if we round that up. Okay? So that's question A. Right? That's the answer. I'm gonna circle that. Now, question B asks us. Oh, sorry. I almost made a mistake. Remember, that says 2 questions. So how much does she have to pay? She has to pay her employer this much money at the end of the maturity date. And then what is the accumulated interest on the loan, right? Well, interest is just your investment minus your principal, right? $13,382.26 minus a $10,000 principal. Her total interest is $3,382.26. So 2 answers here. And then I'd write a statement, right? Then usually you want to write a statement here like she has to pay her employer, $13,000 and 382 cents and blah 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 blah. She has to pay her employer this, and the interest was 338226. So very helpful to add a sentence statement at the end. All right. So let's do question B now. Now, question B is graph the total interest paid over the 5 years. Describe and explain the shape of the graph. So first thing we're going to do here, so we want to do this graph here. So first thing we want to do is, well, if I need graph, I need to do points, right? So graph it. So first I need to do is I need to generate points. So I'm going to draw myself a little table here, just like I did before. We'll draw ourselves a table. Something like that, sure. Again, like, what do you mean a table, a table, a table? Remember this thing up here? That's a table. We're going to use that table. Now, I'm going to look at the one on the left here. I'm going to explain how I get these numbers. We're going to use this one. But again, if I'm doing a graph, what do I need to know? Graph the total interest paid. So all I need to know in this case is the interest that was paid, the principal, and the amount remaining. So in this case, again, I'm just going to use this thing here. I'm going to use theirs as an example. There's a bunch of ways you could do it. I'm just going to do this. Oh, you know what? I messed up. I think I need another one for year here. Yeah. Year. We'll do end of the year. We'll do the amount that it's worth, and then we'll do the interest. So here's the year. Here's the. Oh wait, no. I shouldn't have even looked at their example. Easier just do it myself. So we're gonna have the year. We're gonna have the amount that the loan's worth, and we're gonna have the interest. So here's the year. Here's the amount of the investment, right? A. Here's the interest that accumulated. I guess we don't need this one. All right. So it's a 5-year loan, right? So 1, 2, actually, we always start with 0. Start with 0. And 1, 2, 3, 4, 5. Now, you're not always going to have a nice table here to our left that tells you what's in these, right? So let's think about this for a second. Oh, my stuff just freeze? Okay. Cancel. So at the end of year 0, I had a $10,000 loan. I paid $0 in interest, right? It's year 0. In year 1, however, what's my interest that's accumulated here? How do I calculate that? Well, take this thing up here, right? Take this formula up here. Close out of that, actually. Works again. Better if I do it this way. Right? Same thing. Oh my God. $10,000 times 1 plus, what's the question here again? $10,000 at a 0.6% interest rate. Where's my brackets? 0.06. And that's divided by, compounded annually by 1. That's all to the power of, remember, now I'm just calculating after 1 year. So it's a 1 instead of a 5 there. 10,600, right? So it's $10,600. Well, 10,600 minus $10,000 gives me $600 of interest rate. And then I just do that again and again and again, except this time I start with, again, refresher from last unit. I start with $10,600 for year 2, right? And then it's the exact same thing, right? It's that 1.06 to the power of 1 again, $1126. Am I right? Yes, I am. Sorry, I had to yell at my cat there. I don't know if you guys hear that on the microphone. So 1 1, what did I say? 1126, 236. So the interest in this case, $1,236, and so on and so forth. That's how we're calculating these numbers. I'm just going to use what's in the book now. Again, that's a skill that we have from before, so you should be generating that. You should be able to do this already. After year 4, it was 1 sorry, $12,624.77. Total interest 2,624.77, and then year 5 was $1,282. What? Say $13,382.26, which means the total interest 3,382.26. Okay, so we now have the points to graph it. So draw yourself a nice basic coordinate system here, something like this. And then all we got to do is plot these points, right? Time always goes on your x-axis. So this is the time in years, right? Break it out nice and equal. This isn't a graph introducing thing. Here's 0. Here's 1. Here's 2. Here's 3. Here's 4. And here's 5, right? You're just doing your best. The dollar amount needs to go up to $13,382. Why don't we just go, what was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Everyone's going to go up by $1,000 every single time. Here's 2,000. Actually, well, let's graph the. Oh, sorry, it wants us to do the interest. Read the question carefully, right? So the interest goes up to 33.82. So if I'm going up 15 lines, I'm going to go up by, I don't know, $500 every 2 lines. Sure. 1, 2, 1,500, 2,000, 2,500, 3,000, 3,500. There we go. I have enough now. Now all I got to go do is plot my points, right? Just plot my points. So at year 0, it was $0 in interest, right? At year 1, it was $600 in interest. So go there, put it at about 600. Year 2 was 10,000, 1,600. So about right here. Year 3 was $1,000, and so about, I don't know, about right here. Year 4, 2,600. Sorry, 1910. It was 1910 in year 3. What am I doing? Okay, this crap's messing with me. Doesn't exist anymore. Perfect. Year 1, 600. Year 2, 1,026. Year 3, almost just shy of $2,000. So about right here. Year 4, 2,600. Year 5 was almost 3,400. So if I do that here, let's do a nice red line here, just like kind of draw it in. You can see that maybe it's a little bit harder to see here, but this line is curving up and up and up, right? Which makes sense. The interest accelerates. The interest grows faster over time. It's a little bit more pronounced on this smaller graph here, but I can see that logically speaking, it's starting to look like this. If this was a 20-year loan, it would look something like that, right? So interest accelerates as it goes up. So that's what it would look like. Question C asked us, suppose the interest was compounded monthly instead. I don't want to deal with that in this case. We know how to do a graph. That's just busy work in this case. Solving for a future present value with a. You guys, I think, are able to do that. We're going to jump to example 4 here. So example 4. Solving for payments and interest of a loan with regular payments. This here is stuff like a mortgage or car loan. This is your real world example here. So we're going to do example 4 here. So copy paste this question into your book. And then pause video and come back to it once you got it. All right, so let's start out here. So with question A, here's what we know. So we know he's doing a mortgage. Now, when you do a mortgage, you need a down payment. Usually it's 5 to 10% on your first home. This is how much the home is. He needs to pay 10% of that. And so after he's done that, the bank's like, all right, you can save some money. We'll play a game with you. And the banks will offer him a mortgage loan on a balance of 3.75%, and it's compounded semi-annually. The term, it's a 20-year mortgage, and he's paying monthly, as every mortgage in the world works, is monthly payments. How much will each payment be? To figure this out, you need to find a lot of things. How much is the loan? How much is the interest? How much did I take away on the down payment? And so on and so forth here. So there's a lot of things you need to solve to actually answer that question. So here's what we know. First off, we're going to find the principal, P. Principal is not 225,000. I did not take out that out as a loan. Remember, I had to pay 10%. I had to pay 10%. My down payment was 10% of $225,000, right? 225 times 0.1 was, so I had to pay $22,500 as my down payment, which means my principal is $225,000 minus 22,500. That's two. No. Did I goof up here? Have I goofed up? 225 times 0.1, 22,500. Okay. No, we're good. So 22,500 minus 22,500. $2,002. $202,500 is my principal, right? Cool. I know that the interest rate is 3.75%, which is also 0.0375. I know my term is 20 years here. What's my number of payments, right? How many times am I paying this? Well, I'm paying it once a month, so 12 times a year, times 20 years, 240. So my end in this case is going to be 240. So I should now have all the ingredients to solve this. This is a refresher on what we looked at last unit, right? So go to your apps, go to your finance, go to your TMV solver, and input these numbers. $240, 240 payments. Interest is, remember, you have to keep this as, in this case, you just put it as what it is. It does that calculation for you. Now, your present value, right? P, 202,500. That's how much the loan is for. I'm trying to find the payment, so I'm leaving that at what it is. Now, future value. What would future value in this case be? At the end of the loan, what is this loan going to be worth? $0. It's going to be paid off. So future FV is equal to 0. I'm trying to find my payments. Now, payments per year. Payments per year. It's monthly payments, so he's doing it 12 times a year. How often is the interest calculated a year? Twice. So if I do that, here's what it's going to look like. Right? This is what's going in your calculator. You can also use the online one. I'm going to use this calculator as much as I can, though. So if I do this, how do I find payment again? Go up to it. Enter. Wait, what? Sorry, solve. Alpha, solve. So my payment in this case are $1,197.55 every month. So that is my payment here. Now I want us to think about that. That's how much the payments are. Now, question B, however, asks us how much interest will Jose end up paying by the time he has paid off the loan in 20 years, right? Well, how do I find interest? Well, interest is just the, right? It's the accumulated value. It's the investment subtract by the principal, right? So how much is the investment worth? Well, let's think about this. It's $1,197.55. It's 240 payments, right? 20 years, 12 times a month. That's where I get 240 from. So if I do that, let's clear this. How do I go back? Second function, off. On. Haha. 1197.55 times 240 payments. So in total, come on, you hunk of junk. This is equal to $287,412, which means that that's what A is, right? 287,412 minus the principal, which was 202,500. The 287,412. 287,412 subtract 20 hunk of junk 202,500. Total interest I paid was $84,000 and 912. So $84,912. My God, my English today is just not there. So this is how much in interest I had to pay. Right? So now question C asks us, how much will he pay altogether? Now, really, again, really easy to make mistakes here. Well, what do you mean? We figured it out. He pays $887,412. No, we didn't. What did we forget? Look at the question again. What else did he pay? The down payment, right? So think about this. What did he pay? He had to deal with the principal plus the interest plus the down payment. In this case, normally that'd also be like the house inspection fee and this insurance and this insurance. There's a ton of crap in there. That's more for your financial literacy 30 class. But point being, you add all this stuff up here, right? I know that it was $287,412, and I also know that he paid $22,500 in a down payment. You add that up then. 287,412 plus 22,500. $309,912 was the total amount that he paid. Notice how I'm circling my answer here. So, some more, and this is a simplified version here of a mortgage, right? Am I right with that? Workbooks are on here. Workbooks are on. Yeah, workbooks are on here. All right. Okay, so what do you do now? Textbook and workbook, right? Solve those. That's we're on section 2.1. Your assignment in this case. I want to do that. Yeah, you know what? So for your assignment, there's going to be two of them. There's going to be two parts, okay? So the first part is going to actually be a worksheet. The second part is going to actually be a project, a mortgage project, okay? So it's a little bit different. It's not, hey, just answer these questions in the workbook. And instead, this time you're going to actually have something with a little bit more real world practicality of it, something that, most adults have to do. So, all right, I'll let you guys get into that. If you have any questions or concerns, please reach out to me.